Welcome to Get Your FRQ On. This question is from 2026. It's question 6, and it is not calculator active. In the question stem, we've got a twice differentiable function f and a table of values for selected inputs for both f and f prime. In part A of this question, we are asked to find the limit as x approaches 2 of f of x over x. Since we are given that f of x is twice differentiable, we can conclude that f of x must also be continuous. Since f of x is continuous, we know that the limit as x approaches 2 of f of x must be f of 2. So the limit as x approaches 2 of f of x over x must be f of 2 over 2. And based on the table provided, f of 2 is equal to 3. So the limit as x approaches 2 of f of x over x must be 3 over 2. In part B of this question, we are defining a second function g of x to equal f of x, and we are asked to find g prime of 2. Now, since g of x is defined as a composition f of x, the derivative of g is found using the chain rule. G prime of x is f prime of f of x times f prime of x. With this formula for g prime of x, we can calculate g prime of 2 to be f prime at f of 2 times f prime of 2. And all of these values we can get from the table. F of 2 is 3, so we need f prime of 3 times f prime of 2, which is 9 times 4, which is equal to 36. In part C of this question, we are letting h be a differentiable function with the properties that h of 0 is 10 and h prime of x is f prime of 3x, and we are asked to find h of 2. H of 2 would equal h of 0 plus the integral from 0 to 2 of h prime of x dx, which would be 10 plus the integral from 0 to 2 of f prime of 3x dx. This would equal 10 plus 1/3 of f of 3x evaluated between 2 and 0, which becomes 10 plus 1/3 of f of 6 minus f of 0. From the table, f of 6 is 5 and f of 0 is negative 1. So h of 2 would be 10 plus 1/3 of 5 minus negative 1, which is 10 plus 1/3 of 6, which is 10 plus 2, or 12. And so h of 2 is 12. In part D of this question, we define the function k of x to be the integral from 0 to x of t squared times f of t dt, and we are asked to find k prime of x and k double prime of 3. The fact that k of x is the integral from 0 to x of t squared f of t dt implies that k prime of x is x squared times f of x. The fact that k prime of x is equal to x squared times f of x implies that the second derivative of k double prime, is x squared times f prime of x plus 2x times f of x. That's just an application of the product rule. This implies that k double prime of 3 is 9 times f prime of 3 plus 6 times f of 3. From the table, f prime of 3 is 9 and f of 3 is 8. So we get 81 plus 48, which is 129. So k double prime of 3 is 129. If you like the AP Calculus free response question solutions and want more of them,
Don't forget to like the videos, subscribe to the channel, and you can also find me on X at x.com/getyourfrqon.